Hey everyone, my name is Joe Moyo. I'm a solutions architect with Amazon Alexa, and today I'm joined by Scott Dart. We're here to talk to you about how to build motion-capable Alexa skills for the all-new Echo Show 10. I'm super excited to share details about how skill developers can build new experiences leveraging the new technology that comes with this device. Now, today we're going to first go over what is the Echo Show 10, and then we're going to talk about the different device capabilities. That includes wake word responses, the smart motion APIs, the entity sensing APIs, and we'll go over how to do this with APL and then the web API for games. And we're going to have lots of demos of the experience along the way. So with that, let me introduce the Echo Show 10.
Alexa, call Dad.
Hi, baby! Happy birthday, baby girl!
Hi, Grandpa! Did you get it? Did you get it?
Believe me, you gonna love it.
Alexa, show me cupcake recipes from Food Network. 1.5 cups of graham crackers. Alexa, show me the front door. Alexa, play Mrs. Maisel on Prime Video.
Your weird ask. A weird what? Something I asked for in your contract.
So this is the new Echo Show 10. It is the latest Echo Show device and the first which can turn to engage the customer. And I must say, this is my favorite Echo Show yet. It has 360 degrees of rotation along the base. There's 45 degrees of screen tilt. It has a 10.1-inch HD screen and a 13 megapixel camera. But most importantly, it has on-device algorithms for motion and sensing and can react to the wake word. The Echo Show 10 and the new motion and sensing APIs unlock the next generation of fun and engaging customer experiences that developers can create with Alexa. And by combining the Alexa voice recognition that you know and love already with these new APIs, available in both APL and the web API for games, you can make some truly novel experiences. When I'm talking about the new APIs, I really mean these new sets. So the wake word responses, which will allow you to choose how the skill responds when it is in session to the wake word. The smart motion extension, which will allow you to bind visuals to device position and play choreographed motion. And the entity sensing extension, which will let you read the absolute and relative positions of the entity, of the user who's using your skill. And at Amazon, privacy is really important. So this device was built from the ground up with privacy in mind. So all of the computer vision algorithms which make this possible run on device and do not transmit to the cloud. So we're going to talk about all of these in detail. And for that, I'm going to hand off to Scott Dart to talk about the wake word responses and smart motion extension in more depth. Take it away, Scott.
Great, thanks, Joe. My name is Scott Dart. I'm a solutions architect on the Amazon Alexa team, and I'm going to now take you through the next section where we're going to talk about wake word responses and smart motion extensions. So wake word responses are exactly as they sound. It's what happens on the device when you give the wake word. And we've got three different options that you can configure at the skill level. The first one is turn to wake word. So when you say the wake word, the device will turn to face the speaker, but then it will stop moving. The second one is follow on wake word. In this mode, the device will turn to face the speaker, and then as that speaker continues to move throughout the skill session, it will attempt to follow that speaker as best as it can. And then the third setting is do not move on wake word. So the device will not move at all when you say the wake word. And these options are global options within your skill and give you flexibility for how you want your skill experience to happen. So you can imagine if you're doing a recipe skill in the kitchen, you might want to have follow-on wake word. So as you're walking around, it's going to the screen's always going to be visible to you no matter where you are. But imagine that you want to do something more advanced where the player or the customer movement controls action on screen, in that case, you might not want the screen to move at all. And so that's where you might use the do not move on wake word option. And these options, while you can set them globally, you can also override them locally, and we'll talk about that a little bit more as well. But before you do any of this, you've got to enable these wake word responses, and there's a couple ways that you can do this. In the developer console, there will be a toggle under the interfaces section that will let you configure the wake word section. You can also do it in the skill manifest as shown here. And it's important to know that these wake word responses can be disabled by the customer. Motion can be disabled by turning off the shutter of the device or by telling the device, turn off motion. And in that case, the motion will not happen regardless of the setting in your skill that you choose. And so now we're going to do a quick demo that shows you a little bit of how the follow-on wake word behavior is going to work.
Alexa, open skill reviews by Arun.
Welcome. Select a skill review to watch or say something like play the first one.
Okay, so those options are great. Again, if you just want a global experience that enables motion and feels delightful throughout your skill. But if you want more fine-grained control, where in part of your skill you want the follow behavior, and part of your skill you want to turn off motion, or you want to mix and match or do some other things, you've got the control to do that at the turn level. And so this is what we call the APL Smart Motion extensions. So it lets you specify the motion behavior to use in response to the wake word like we just showed you, but instead of it being global, it's at a per APL document level. You can also run specific commands, and you can run pre-built choreographed motions, which we'll talk about later, and you can retrieve properties about the state and the capabilities of the device, and use event handlers to respond to positional changes in the device state. So let's dive in and talk about all of these. Here we've got a quick screenshot. It shows the developer console. Again, shows you how you can configure the global wake word response, but also shows you the interface where you can enable the smart motion extensions, because they do need to be enabled at the skill level. So again, through the developer console or through the skill manifest. And then on the individual APL documents, we're going to use smart motion extensions. You're going to want to enable it as well. And the example is shown here. Now let's dive into some of the new extension commands that are available. These will allow you to trigger certain behaviors on demand, and we'll go through each of these in more detail in the following slides. So the first one is the set wake word response. So this changes or overrides the built-in wake word response motion behavior for the device. So if you had set do not move on wake word as your global setting, you could change to one of the other settings on demand and mix and match that throughout the course of your skill. And here we show an APL document that's got a button that basically just toggles between the different modes. So you could change that on the fly throughout the skill. And this is going to override what your global skill setting was. And this is going to remain in effect for the life cycle of this document until you run another command that overrides it again. And so your best practice, if you're building up a very complex skill with many APL documents and many different behavior, I would recommend that you explicitly configure the wake word response that you want in each document, just so that you don't have to remember what was the last document and am I sure I'm inheriting the right behavior. You probably want to take control of that yourself if you're going to go down to this level of detail. Okay, the next command you can run is follow primary user. And so similar to the wake word behavior that will follow primary user, you can just initiate this behavior, this motion to happen. And so it will direct the device to follow the most engaged user, which the device will do its best to determine. And it will cancel any current motion that is running from a previous command, including the wake word response. And then speaking the wake word will also cancel this motion as well, since that will still be in effect. Now we've got turn to primary user. So just like the follow user, this is a turn to the primary user, but then stop moving. And again, the device is going to attempt to identify who the primary user is and turn and align with that customer and then stop immediately. And this will again cancel any current motion, and speaking the wake word will override and interrupt this behavior as well. Go to center is exactly as it describes. The device is going to have a calibration range. When you set up your device, it's going to attempt to evaluate its surroundings and know how far it can go in either direction, but it's going to have a notion of where it thinks center is. And so it will move to that center position with this command. And again, we'll cancel any current motion that was running previously. And then we've got stop motion. So this is something that you can use to interrupt any previous motion behavior that's happening for any other reason. Okay, now we get to play named choreo. So choreo is a new term that we're introducing. It's short for choreography, and it is a pre-built set of motions that can happen. And right now there is one choreo that is defined. It's called screen impact center, and basically the device will shake back and forth when you run this command. Although the design pattern allows for many more choreos to be introduced in the future. So you're going to want to verify that the choreo you want to run exists and is supported on the current device, which you can query from an environment variable that we'll talk about later. And just like with the previous behaviors, playing a choreo is going to cancel any ongoing motions, including previously issued choreos. And so now we're going to do a quick demo showing you what this screen impact center choreo looks like. Okay, now we're going to talk about data binding. So you'll have access to a device state object, which is a live data object that represents the current device physical state and capabilities. So that includes errors. It includes motion limits. As I said earlier, the device is going to evaluate its surroundings and set limits if it runs into something so that it doesn't keep hitting a wall or something like that. So you'll be able to query what those limits are. It'll also surface poise. And so poise is the angle and the velocity of the screen itself. And so the device is going to rotate on two different axes. And the easiest way for me to understand this is poise is like, turning your head. This is side to side. So it's both the angle and the speed. And then screen angle is the, more up and down, like you're nodding your head. So it's the angle of the screen. And so you can data bind to any of these properties from the device state object. And as I mentioned before, there's also environment properties that are static that you can use to query the version of the software, the wake word response that's configured, and the available choreos on the device. So if you are going to use choreos, you want to use this environment variable to make sure that the one you're planning on using is available. And now we're going to do a quick demo that shows how you can react to data binding in real time. And so the demo that we're going to show you just uses the wake word response to follow the primary user. And then it's going to use the absolute angle position in data binding to know what the position of the screen is. And then it's going to use that to define an offset and pan through a panoramic photo. So you'll see as the screen moves, the photo is going to pan because it's based on that angle.
That's a plane in a lake. Move around to look around.
Okay, now what happens when things go wrong? So as I mentioned, the data binding object, the live data object, surfaces error codes to you. So you can find out if, for example, motion was disabled by the customer or there was something blocking the device and motion was unable to proceed. If your skill experience really relies on this, then you can react appropriately in the moment. And then finally, let's talk about event handlers. You can respond to the on-device state changed event to get both the current state and the changed state. So you will get a copy of that data object that tells you the device state, and you can compare and see what has changed and then react to those changes in real time in your skill. And so here we have a quick code example that is data binding to an error code. So in one of those previous examples, if I had stuck my hand out and blocked the screen from moving, the error code would then have shown on screen because it's data bound to that error code, and the on-device state change event would have raised to surface this error. Okay, now I'm going to hand it back to Joe, who's going to talk to you more about entity sensing.
Thanks, Scott. Now I'm going to talk about the new entity sensing extension. So devices that have entity sensing capabilities can detect the presence of a user. You can use the entity sensing extension in your APL document or your web APIs for games web application in order to get information about the user position in relation to the device or absolute. And your skill can then respond to those changes to update the visual presentation. And you can respond to things like when the customer changes or even goes off camera. So this allows you to use player movement as a direct input into the game. So multimodality now includes more than just visuals, touch, and of course audio, but customer motion as well. So this unlocks a lot of brand new engaging experience potential. Now let's talk about getting started with APL. So just like with the Smart Motion extension, you're going to need to declare the use of this in your skill manifest, either through the UI of the console or in the skill.json file. But once you've done that, you can now make use of entity sensing in your APL documents. So start by declaring the extension in the extensions block, which you can see here on line 4. Now, once you've declared that you're going to use entity sensing, you have to then define certain values so that you can then reference those later on in the data binding context with APL. So here we're declaring entity sensing state name and primary username. Now, once we've done that, we can then reference these values. So first up, we have some environment properties. So these are just static properties that are available in the APL data binding context. And they're going to reference device-specific values here. So first up, we have version. This will tell you the version of entity sensing that's running on device. And then we're going to see the horizontal and the vertical field of view. These are both values in degrees, which are going to tell you the field of view in the horizontal or the vertical extent. And then next up, we have access now to the live data properties. So these are really important, and they're going to be added to the APL data binding context. So they're simply data objects which are going to tell you what is going on with the primary user and the entity sensing state. And we're going to be able to reference these throughout the lifecycle of the APL document, and they'll be changing throughout. So first up, we have primary user, and we can see an example of that on this screen. So primary user has an ID. This ID is specific to the individual for that skill session. So when that person goes off camera or a different entity is detected, that value is going to change. If that first person comes back, the device is going to attempt to match that to the same ID as before. So you can imagine some really cool possibilities with multiplayer games. We also have the isActive Boolean property. And this is simply going to tell us whether or not that detected entity has spoken the wake word. We also have a Boolean for isSeen, which will tell us whether or not the entity is seen. And then we have poise. Now this poise is a little bit different than what Scott talked about, but this is going to tell us the position of the customer, both in terms of absolute angle and relative to where the screen is currently pointing. Now we also have entity sensing state, and this is primarily going to hold error codes and an error description. This is really important as it's going to let you deal with scenarios where the entity sensing state might not be working correctly. For instance, if you're in a low light scenario, or if do not disturb mode is on, or the camera shutter is physically closed, the entity sensing is not going to work and it will report an error code. So let's see these live data properties in an APL document. So we have here a simple APL document which has a couple of text components which are going to print out some of the values. So we can see that the primary user ID is being printed. We're using some of the Booleans and showing the values of isActive and isSeen. And we even have a conditional statement using, just like you would any other data binding context information in any APL document. So you can see those in use here. And note, we're referencing the names that we've set in that settings block above. But you can imagine some really cool scenarios that you can create by using the when clause on different APL documents, or using this within the tick handler. So let's talk about the event handlers that you get access to as well. So on entity sensing state changed is going to tell us when there is an error. So this event handler will be called, and we're going to see a data payload similar to what is being shown on screen. Now, this data payload is going to contain the values that have changed and the current values of that object. So for the case of entity sensing state change, that will tell us the error code and the error description. Now, we also have onPrimaryUser changed. And this will be called anytime there's a change to the primary user property except for the poise property. So the angle of where the customer is won't invoke this. So some examples of where this will be called is the device detects and assigns a new primary user, or if the device no longer detects a primary user. Just like the other event handler, you're going to get the new value and what has changed. So you can make use of the payload to change the presentation of your skill at runtime. So let's take a look at an example that is built using the entity sensing APIs.
That's a plane in a lake. Move around to look around.
This is very similar to the demo that Scott showed earlier. In fact, it's even using the same panorama photo. However, instead of using smart motion and a wake word response, which follows the customer on wake word, we're instead going to use the customer position rather than the device position. The big tangible difference here in experience is that in this case, the customer doesn't need to physically walk around their table as much. They can simply lean back and forth in order to experience more of that panoramic image. So there is no option that is better or worse necessarily. They're just different. So if you have something like an exercise skill, it might make sense to have them moving around more and make use of the smart motion. Whereas some other skills, you might rather prefer to use the entity position instead. Now that we've seen some examples of all of these new APIs with APL, let's take a look at how you can get started with the Web API for Games. The Web API for Games is going to add 2 new JavaScript libraries that are going to be available on device, one for entity sensing and one for smart motion. The wake word responses that you set at the skill level and everything you have to do to enable it in the skill manifest still applies in exactly the same way to the Web API for Games experiences that you build. So the JavaScript APIs are pretty much a one-to-one in functionality with what's available in APL. Let's start with a demo of what can be done with this.
Alexa, I'm ready.
Shuffling.
So this is a really cool demo as it combines the wake word policy of follow the customer with the smart motion device state in order to check the angle every frame of the game and move the camera accordingly. And this is navigating around a 3D scene. This particular example was built with Three.js. Let's take a look at how you can get started adding this into your skill. First off, you're going to need to include the JavaScript libraries. So there are 2, the Smart Motion JavaScript library and the Entity Sensing JavaScript library. And of course, you'll need to include the Alexa JavaScript library as well, which is not shown here. Now, once you've pulled these into your web application, here I'm adding them into the HTML of a static website. You can then, in your JavaScript code, initialize the Alexa object. Now, this looks very similar to what you're doing today. However, we now have a new version of the runtime for the Web API for games. This is version 1.1. So your skill is going to need to report that before you can make use of these new extensions. Now, we also have a change to the capabilities block. Now there is a set called extensions, which is going to tell you all the extensions that are available on device. This will be accessible from within the successful callback when you're initializing the Alexa client. So here on lines 3 and on line 6, we are checking that the appropriate extension exists, and then we're initializing it. Now note, I omitted the rest of the Alexa initialization as well as the error handling, but you definitely want to consider how you're going to test your application locally when the Alexa JavaScript libraries are not available. So it's only going to be available on devices which support this. So when you're booting this up on your development machine, consider how you might test the experience otherwise. Now let's talk about the Smart Motion JavaScript library. So all of the commands that Scott shared earlier are available one-to-one with the JavaScript side. But instead of using an APL construct to call them through onMount or execute commands directive, you're going to use the smartmotion.method name. So in this case, if you wanted to set the wake word response, you would say smartmotion.setWakeWordResponse and pass in the appropriate wake word response type that you want to set. Or you can call something like smartmotion.stopMotion to stop all the motion running on the device. And just like with the APL commands, any motion is going to cancel other motion that had already been started. The device state is still going to return to you all of the information that you need, such as the device poise, the motion limits, the screen angle, and any error code and error description. The big difference, though, to APL is that you're going to be able to access all of these properties and methods from anywhere in your JavaScript code. Now that could be in your onMessage callback, such as when you get a response from the skill side, or it could be in your main update game loop like you're seeing here, where we're making sure there is no error and then updating our camera and game objects according to the device state. Now let's see an example of Smart Motion being used within the Web API for games. So I think this demo is really cool because it makes use of the APIs for the device state in the main game loop in a really novel way. So instead of using the follow on wake word response for the wake word response type, we're instead using the turn to wake word, and we're still updating the device position, but it's through the player physically moving the device. So as they turn the device to the right, the race car moves to the right, just like you're driving in your car. So it just really gets me thinking on some of the cool things you can do with this. Let's talk about entity sensing. So again, for entity sensing, the same basic functionality is exactly the same. And the API is even the same as with APL. But you're going to be using this through that JavaScript library. So you're going to be able to detect the ID of the user, whether or not they've spoken the wake word, whether or not they are seen, and the customer's poise, so that absolute and relative angle. And just like before, when the customer changes to a different entity, that's going to change in the JavaScript library as well. So you can check this in your update loop and react accordingly. So I have one more demo to show here. So this is a demo of the myCactus skill. And we've combined a few of these different APIs together. Let's see that now. Here in the myCactus skill, what we've done is we've used the entity sensing API in order to move the angle of the camera in the scene. So as the player moves slightly back and forth, it rotates the in-game camera. And we chose to go with this approach because there's already a limited field of view in the camera inside the game. So we didn't want to give the impression that moving around would let you see even more of that scene. But we've also combined the Smart Motion extension here. So by touching the cactus dances, and the device gives a little dance along with it. It makes for a really playful experience. This is really cool stuff, and I'm really excited to see what you all go out and create using this new technology. So between the Smart Motion extension, the Entity Sensing extension, and the new wake word responses, you can enable a new modality of skill interaction. And we've seen how this can be used both in the context of APL and the Web API for games. You can learn more at alexa.design/motion. And if you need an excuse to start building with this now, check out the Beyond Voice Hackathon. So these new APIs for the Echo Show 10 are eligible for rewards. So you can get started today in the simulator for your APL skill. And in addition to using APL, you can use the Web API for games or even APL for audio and compete for prizes. So I'm really excited to see what everyone builds with this and how you all leverage all of this awesome new multimodal technology that we have available now. So with that, I want to thank you all on behalf of Scott Dark and myself, Joe Moyo. Thanks for watching.